Back in the old days, we didn't have to worry about that because we didn't have the technology to be able to do those mass notifications. Okay, so recording's in progress. I think I want to share my screen. Go ahead and hit share. And we'll shrinkify that. Move that down here so it's out of the way. Camtasia software is broken and I refuse to pay to upgrade it, so I guess I have to live with it. All right, so today's topic is blank. Not really. It is files. And we will go look at the instructor notes briefly, and then we'll kind of flip between them. I'll open up a working notebook and we can try some of the things out, which should make, if there's a lab, that'll be a good thing. And if not, so be it. So let me go ahead and connect to Amazon Web Services and get some clock cycles from that. So not that, it's this class. Not the right link. Yep.
For Friday for the test, do we still have to come here?
No. No, you can stay in the luxury of your Fleabag apartment or wherever you live.
Under a bridge.
Under a bridge. You just need your internet connection and log into your Blackboard, because that will take you to the two parts of the exam. There'll be one that'll be labeled part 1, and another one called part 2. You got to do part 1 first, because part 2 doesn't become available till after part 1's over. So part 1's an hour, part 2's an hour, unless you are in a category where that's not so, but you'll be taking, in those categories, they'll have an exam by a different. The class starts at 4 and it ends at 6. And you should have plenty of time. I can't, unless you are indeed living under a bridge and you get a bad night's sleep Thursday night because it's still cold. You should have plenty of time. Shouldn't be a problem. Now, if you can read our thinking, because I don't do the entire exam myself, so it's done by a team. So only 20% of the exam has my input to it. Since that's why I don't tend to do much of any review. It sounds grotesquely unfair, but in a way, it's actually a really good test. You get in a real exam. You don't know what's coming, and do the best you can. I don't think we're intentionally trying to hurt you, but you may find some questions just confusing. Just do the best you can. What more can anyone say? Nothing. Okay, so today the intended topic is files. And let me get the recorders on and sharing my screen. So I think this is good. I learned earlier today how I can edit my Zoom recordings, assuming that they get done. So I can record bad things and get them deleted before they get uploaded. It's a pain in the butt to edit the files, but it can be done. Okay, so today, files and file systems. We're going to do some opening and reading. Claims will use loops to read text files, and then writing, and then downloading files from a remote server, creating and deleting. So that's supposed to be the lesson outline. Our objectives are to be able to describe files, file types, and importantly, what a search path is. Then we'll demonstrate creating a file and deleting a file, opening the connection, putting stuff into it, opening connection, getting stuff out, and closing those connections. And then it claims we're going to go all the way. I don't think, it looks like I do have. So if I go fast enough, which I'm obviously not doing now, we can get to how to directly connect or get a file from a remote server, which is the whole point of why this particular lesson is in the entire course anyway. Because in the olden days, we would hand you the file on Blackboard, or you would right click and download as. Okay, that's why that's bugging my net. So let's start with files and file systems. So file is just a collection of zeros and ones. It's here to define as a computer resource for recording data discretely, and not in the secretive context, but putting it somewhere on a piece of hardware so that we can recover the file later on as needed. Just like words can go on paper, information can go into a computer file. The files can be edited and transferred through the mighty internet on that particular computer system. You have all, if you're here right now at Tech, you have all dealt with files, whether you've known it or not. So when you log into the Texas Tech website and it starts to extract money from you in exchange for letting you click or doodle on stuff, there's a file on you, just like there's one on me, that keeps track of all those transactions. And so if there was a catastrophic failure of the Texas Tech servers, in theory, if those files are preserved somewhere off-site, which is supposed to happen every night, we can recover in a matter of hours and be back up and running. In practice, recovery doesn't always go that fast, and there's a lot of reasons why that is. Some of them are institutional stupidity. So when we're in our computer, we store things in a file system. You can think of a filing cabinet. That's a perfectly good mental analogy. So let me go over to a Jupyter Lab instance. So here, everything in this left column is part of a file system. And in this particular instance, my computer is pointed at a particular directory or folder in that file system. And the directory is, the tilde means whatever Sensei's home directory is, and then CE-1330 web root, which is the web root that renders all this stuff for the class. So we are on the Amazon server right now. If I go to a particular directory and a file in the directory, see if I can get this to work without a mouse. It's my right click. Is it that one? Here we go. If I copy the path, so I took the file exam3-2021 IPYMB. That was probably a bad choice on my part, but since you're all physically here, I don't mind doing it because you should get a teeny reward for showing up. So I pasted the entire path that I just searched in the file system. And so it's telling me that the file 2021-3 deploy IPYMB is located in a directory called exam3, which is part of a directory called 5 exam problems, which is part of a directory called ENGR-1330 web root. And then what you guys don't get to see, that's part of a directory called Sensei, which is part of a directory called home, and home descends off the root. So it's off the highest level directory. Let me show you a picture of that whole process, although not necessarily, not at all the same server. So here is the file system on my office machine as of whenever I did the screen capture. I don't know when that was, probably a few months ago. And so on my office machine, it's running the Macintosh operating system. So the equivalent of File Exploder is called Finder. It's poorly named because you can't find a damn thing in it. But the red arrows are indicating the path to this directory called source, SRC. And let's suppose we were interested in frontmatter.tex as a file. So the way we would specify that properly to the computer would be whatever the root level is. In my case, it's root Macintosh HD. And the next one is going to be users. Next one is Theodore. Now we get to my desktop, commander.ttu.edu, 6977 data archive, final report, source, front matter.tex. So that whole long litany of wordage is the absolute name of the file. We normally are accustomed to working with just the last part of it, just the file name, by manually navigating to the correct directory. We don't have to. If we specify the absolute file name, we can get to it without having to change directories or click on doodles and pictures and stuff. So here is the same file path. Users Theodore, well, root is obscured by the red box. Root users Theodore desktop at commander.ttu.edu 06977 Dataverse archive. There is a escape character and a blank for the to get the space copy. Final underscore report source, and then in that source directory is one of the files here that we could choose. So the path is part of the file name for most practical purposes. So what we have been spending the last few weeks is in the lab, Josh has emphasized, go ahead and download your Python notebook, put it where you're putting everything else, and any supporting material goes in that same directory. We've been tricking you because we've been saving you from having to do the whole path specification. So for example, I could have on my computer a file named guest.conf right here and right here. So they have the same file name. Oh, that's a problem, right? Well, it would be if that was the entire file name, that would be a problem. But it's quite comfortable as far as the computer is concerned. The actual file name is what I have highlighted there. Users Theodore MyGit at atomic candy hurry sensors.git guest.conf and Ascii Apache 2 users guest.conf are different files. They're in different paths on the file system. The usual delimiters for specifying the path are either the / shown here, \, or some operating systems will use a colon as a delimiter. There's probably other delimiters that are used in weirder operating systems. But generally this one or the / going the other direction works. And the / and / as you encounter that is literally going to be the difference between a Microsoft product and everybody else. Everybody else / Microsoft, just to be different, \. And Microsoft has improved over the years. They can usually recognize the / automatically. So we have different types of files. We have the ones that we can read if we open them in a text editor or just list them in our terminal window. Those are text files or Ascii files. Call them either of the two, means the same thing. And there's nothing particularly special about them except that we can interpret them without any unduly specialized software. Obviously, we have to have a text editor or we have to have a functioning command line interface window, and we can just look at them. For instance, let's look at my RSA keys. Let's try it correctly. So I'm using something called the less filter. And I'm going to try to list the contents of the file named id_rsa.pub. And it currently is located in root users Theodore. Oh yeah, this is directly off of my user root. So I do that, and at first glance, Is that a text or one of the other weird file types? So first glance, it looks kind of weird, but everything there is a character that you recognize. You recognize there's 3 capital A's in a row, and then a capital B, and then a 3, and then an N, and a lowercase z, and then there's a bunch of those. That happens to be a secure shell key. So even though it's a text file, it doesn't make much sense to us, but because we can recognize all the characters in it, that's what a text file is. So we're more accustomed to text files that make sense to us. And I don't think I have any good examples of a, wonder if I can list a tar file. There we go. This worked out good. Okay, so I got lucky. So we have this other file. The name of the file is, I'll start off CE-1330-Sys.tar. The extensions aren't particularly important, except to Microsoft products and various other word processors. So it's telling us this might be a binary file. You sure you want to go ahead and look at it? And of course I did. Now, as a binary file, there are some characters there that we can recognize, but mostly it's giving us the character squiggle up arrow. And that's how we know it's a binary file. I think I have a hex editor on here, so you can sometimes look at the contents of a binary file with, is it hex edit? I think it's hex edit. If it doesn't work, we're not going to belabor it. So there's the same file in a hex editor, and that one is readable in the sense that it's giving us the hexadecimal equivalent of each character in the file. And occasionally hex editors are useful for us. If there's something broken somewhere in a file, we know what to look for. We can change a couple of the hex codes and turn this 177.00 0.1146 into whatever we need it to be. But that's fairly high level stuff, and if you're doing that, it's usually more efficient just to fix whatever you broke. Control-C. So those are examples of the 2 kinds of files, text and binary. We have a lot of files that are binary. I guess technically they're all binary files at some level of abstraction. So binary files, we normally have to read them with a particular piece of software. The example I showed was a hex editor. There's also directory files, and these are files that contain information the file system needs to be able to find the other files. And you can see them in the screen I just deleted. So those ones up at the top with the dots in front of them, those tend to be directory files. So .anaconda contains the information for the file system to send everything to the Anaconda package if it's indicated. Normally, we're not going to, certainly in this class, we're not going to deal with directory files. So how do we manipulate files? We actually have done these examples of examining our local directory, so we'll just skip forward. And let's go ahead and create a file and write to it so that if there is a lab in 30 minutes, you'll be somewhat forewarned. So I need a new launcher. So do we want to launch a notebook? We sure do. We'll use the Python, probably should use the Python 38 kernel. We'll see what happens. So here's an example. I'm going to open a file called, I need to get out of that directory. Do not want to work in my exam directory. I want to work off the root. off the class root. Off the class root. Sometimes these things are stubborn and they do not take instruction well. There. Okay, so now I am operating in what directory? In this example, I'm operating in engineering 1330 web root. So you obviously can't replicate this on your machine unless you have created a directory called 1330 web root. But what are you all using for your default file directories for all your Anaconda stuff in this class? Or are you just willy-nilly putting it wherever it'll work? Yes. Well, I'll presume that maybe you created a directory called engineering 1330 my stuff. So in that case, you're working in that directory, and we have created a notebook called Untitled 2.python, and I'm going to go ahead and execute this script. Here's what it's going to do. In the notes, there was an example on how to see if my first file already existed. I'm pretty sure it's not here, and it won't hurt anything if it is. So we're going to create a connection from our notebook to the file system on the computer. And we create that marvelous connection using the open function. And in the open function, it's expecting us to tell us what to open. And then the second input is what we're going to do with it. So we choose W, which corresponds to write. And I've never tested the conjecture, but I bet if we put the word write there, it would work too. But I'm not going to test that right now. And now, once we've created the connection and we don't get our pink screen of encouragement, we're going to create a message called my message. It's going to be comprised of a string called message in a bottle. And then we're going to write that message in a bottle using the object named external file. And the object named external file can be any name. It doesn't have to be that name. But I pick names like that so I can kind of see what the example is doing. And to the object, we're going to use the method called write, and we're going to tell it to write the contents of my message. And then we're going to close the connection. The purpose for closing the connection is to complete the process of sending that string message in a bottle from our Jupyter notebook out to the file that's in the file system. Oftentimes you can get away without doing that, but if the files are extensive, we have a lot of characters in them, if you fail to close it, the characters are sitting in a buffer somewhere and they just go poof. So let's go ahead and run it. And wow, that was remarkable. Look at the output. It doesn't look like it did anything, but if we go to my first file.txt, which if you were paying attention, miraculously appeared, and we look in the contents of it, look at that, it's got message in a bottle in it. Is that cool or what? Or what? We can list the contents of the working directory, but in our case, we have it on the left. And so let's read from our file that we just created. So I will grab a script for reading. Maybe I will. So it's going to open a connection to what? My first file.txt. And it has a code after the connection name or the file name, R. R is the first letter of what word? Read, and a lot of other words, but that was the word I was after. Thank you. So we're going to create the connection. We're going to set the object named external file to operate on the read methods. And then we will read the contents from the external file. It looks like you are going to miss your lab.
Yeah, I mean, no.
I'm going to go to lab. I'm going to go to 5, and then I'll just not start the lab, and I'll suppose I'll send an email to everybody. Okay, I just confused myself. So we've created an object called external file. In that act of creation, there's a method associated with it called read. And so we will execute the read method without any arguments. And by doing that, it says just read the entire contents of the file if you can. And if it can't, what does it do? If it can't read the contents of the file, it says go find the pink rectangle and display it for the user and tell the human being that they're stupid and we're coming to harvest them as fuel in the future. And it's going to put the contents of a file into another object or variable, and the name of that variable is, I'm doing a test here to see if you can follow along. Silly string. Then we'll close the connection, and that should guarantee us that all the contents of whatever was in the file got jammed into silly string. And then finally, we'll print silly string and see what's in the file. And we should get message in a bottle regurgitated back to us in an output cell, sure enough. So the usual thing to remember about reading and writing files, open the connection, read or write, do whatever you have to do, close the connection, and then continue on processing. So if it's a writing activity, you open the connection, perform the write activities, close the connection. If it's reading, it's open the connection, perform the read activities, close the connection, then perform any other activities. And they get much more elaborate than we're showing here with real simple examples. I believe those examples are called supremely simple. So that 3-step protocol right there is what it takes to open and close the connection. So I have an example here of what happens if we attempt to write or read without actually creating the connection. Obviously, we're going to get error. So we're going to try to read. We're going to try to put message in a bottle into my message. That part will work just fine. And then we're going to try to write that to external file. But recall, we've just closed the external file. So as of right now, there is no connection, and it tells us that in the warning message at the bottom. Input-output operation on a closed file. So if you see that, you don't need to email me and say, I did exactly what you did and it didn't work. Because if it didn't work, you didn't do exactly what I did. If you see that, it just means you have not opened the connection to the object that you think you have. And it's usually a simple matter of, at worst case, 2 lines of code in the right place. So an open before the my message and a close after the write. And if I did the other example, we get the same error. The error message looks indistinguishable, but it happens when we are reading without a connection. Okay, so to update a file, just like we did with lists earlier, the keyword is append. So if we have a file that already exists, we want to add stuff to it, we append it. If we want to remove stuff, we do an appendectomy. There is no function appendectomy. I was being silly. See, I can make myself laugh too. So I'm gonna, let me do it right here. Delayed understanding. Oh, so they're censoring me. They're processing all the. Actually, this would be a handy hearing aid that would do that. So we'll open a connection to our external file. We're going to connect to my first file.txt. And in this case, we're going to write a new line character. And then we're going to add the string I love rock and roll, put another dime in the jukebox, baby. And then we'll add another string, including the line feed. The waiting is the hardest part. So we've got Joan Jett and Tom Petty, well represented in our script. And then we will create a list called 1, 2, 3, 4, 5. And then we're going to look at a couple of different ways to write the contents of the list. One of them is to use that function. The other one is to use that function. And that seemingly complex thing has a purpose because it will write the list all on a single line instead of putting the 1, then the 2, then the 3, then the 4, then the 5. And finally, we'll close the connection. So when we run that, nothing happens. Oh, that's because we wrote to the file. So if we go look at the file, you see what we have in there. We have a message in a bottle. I love rock and roll. Waiting's the hardest part. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you will observe, if you're observant, that there is a 6th row in the file. Now, how did that end up there? Or why did that end up there? If we go back and look what we instructed it to do in the last write statement, you'll notice that we had a new line character there. So it puts the file to the new line, and now it's waiting for more input or output, as the case may be. I thought I moved you out of the way, you silly box. Everybody wants their. If we go ahead and let me touch your computer, I'll destroy it. If we go ahead and open a new connection and do some more writing using the append feature, which is the A right there, it will just add content to the file. So we just appended our existing file, and we should have I love rock and roll again. Except I need to close and open the file. There we go. It does not automatically update the contents of a file, except for the Python notebook files. So there's what our file looks like now. And if we repeated that indefinitely, we can get the file longer and longer and longer. To delete a file, there's several ways to do it. You can do it this way. Just go to it and delete it, and it'll say, "Are you sure?" It's like, of course I'm sure. I know what I'm doing. You can also delete it from within a script, either using the SYS package, which installs as part of Python core, and then this exclamation point symbol to tell it to execute a system command. And the example I have here will delete it on my computer and on the Amazon server. Alternatively, you can use the OS package, which also is a core Python package, and use the os.remove method to remove a file. Deleting files from within your own scripts is potentially dangerous to your file system, especially if you're first starting out and new to this stuff. So I would suggest, as you're learning to do it, first do everything in a directory that you can afford to lose. And over time, you'll get comfortable with this, and at which point it's perfectly fine to delete a file from the script. So I'm going to go ahead and copy that particular script into my example. Let me go ahead and recreate all the files. Okay, so my file exists. I've just recreated it. Keep your attention over here to the visual display of the file system. And now I'm going to import the OS. I'm going to select the file to kill as my first file.txt. And then I will try to kill it with OS removed. And if it's successful, it should exit. And then we're going to print back to it. The file that I wanted to kill is either missing or deleted. And in the past, I've just left a way to make the thing more readable. If it failed, I guess you could put a message there for the failure. Sure enough, my first file is gone, and it's gone over here. All right. So let's suppose we wanted to read data from a particular file. I'm going to go and I need it. Trying to figure out an efficient way to do this. I guess I'll have to do it this, since we are pretending that we're in lab. So let me read to you what we're going to do, and then I'll go ahead and demonstrate. Okay, so we're going to get 3 files from a remote website. We're going to get a file called a.txt, b.txt, and x.txt. So 3 files. And to get that, we go to where it tells us, and we need to save link. And downloads is as good a place as any. So what I'm doing is I'm doing a right click, save link, and I don't know what it is in Windows. I think it's save target as, or it used to be. Right click, save link, and I need x.txt. Where is that? Right down there. All right, I now have them onto my laptop. So now we need to get them over into here. And we're going to do that with a fairly lazy way to do that. We go to downloads. I think I can do 2 at a time. Drag them onto in my case, on a server. In your case, you're dragging it to the directory where you're doing your work. And the drag drop, I think, is the same, whether it's a Windows or Linux or Mac OS. So there's my file there, X is there, A and B. Okay, so we have everything we need to run the examples. And let's go back to the example and then follow the instructions. I'll go back to the top of the sheet because that's what it wants me to do. Okay, here we go. So here's the instructions. And the purpose of this particular example is to show how to read a file line by line, element by element. So here's what our file A looks like. It's just a collection of numbers, 5 rows, 5 columns, 4, 1.5, 0.7, 1.2, and so on. Our file called X is a collection of 5 numbers as a column. And our file called b.txt is also a collection of 5 numbers in a column. And what they are representing is the matrix vector multiplication, a times x equals b. And we want to test if that's true. So how would you test if that arithmetic statement is true? I'm not asking you Python stuff. I'm asking you kind of to think that out. So if we want to test if ax equals b, what's it telling us to do? It's suggesting that we compute the dot product of ax, and when we do that, we'll get 5 numbers out, and then we can see if those 5 numbers are the same as the 5 numbers in b. That's really all that it's doing. Oh, if you've got the problem-solving protocol written right there, that was the way. Allocate the objects to store the file contents, read a, b, and x from their files. Echo the inputs, in this case it's pedagogical, but sometimes it's useful. Perform the indicated matrix arithmetic. Test if the right-hand side is equal to b. If it is, we report the results. So we were going to skip this step because we already looked at what's in the files. So first, we're going to create ourselves a fairly simple Python script. And we're going to create placeholders for these various things that we're going to read. So we're going to have a matrix called A. We're going to have a list called A matrix. Currently it's null. It's going to store whatever we read in it. Same for X vector, same for B vector. And then we have some indices that will play an important role coming up. Now we're going to read in the A matrix. And as I copy it, we're going to go ahead and take a look at the syntax. So we're creating an object called local file. We're going to open the connection. We're going to associate that with a.txt. We're going to set it to attribute read. And then we're going to use a for loop. And what we're going to do is for each line in the object that we just connected to, we're going to append to a matrix that line where we treat everything as a float. And we use the strip function to take out the spaces between it. And we're also going to count how many columns there are by getting the length of the list named A matrix from its 0th element, which would correspond to its first row. So our first row, if we go back and look at the picture, has 5 things in it. So we go ahead and run that, and if we, when I execute, so there's our A matrix that we just read, and it looks the same as it did before. So this line essentially took that part of the A matrix file and read it in as a list. Let's go look at what A matrix looks like in the operating system. So there's the A matrix. There's what it looks like after we read it in. So we'll do the same for the other 2 parts. Well, it looks like we're going to echo it back to ourselves. So the echo step for big matrices is an act of dumbness because it will clobber your standard input output and you won't learn anything from it. But there's the matrix printed back out. You'll notice the for loop is something we're familiar with now. We have a counter called I. We have the range function starting at 0, ending at how many rows there are in A, incrementing by 1. And then we're going to print the contents of the A matrix I from 0 to the column number, which is why we counted the column number in the first place. Now read in X and essentially do the same kind of thing. We can print the vector. And lastly, we'll read in B. If you study these carefully, which you're not going to do in the next 9 minutes, because it looks like everybody has already mentally left the room. You'll see that there's slight differences in structures of whether it's a 2-dimensional array or just a column. Let's go ahead and look at the contents of the B vector, just the B vector, not everything. So it looks like the B vector was read correctly. And now for the money shot. Let's go ahead and we will perform the multiplication. At this point, you have to know how you do vector matrix multiplication. We haven't really introduced that. So take it on faith that it's going to take the element of A multiplied by the first element of X, first row, second element of A, second element of X, and add them up. And it's going to do that 5 times, once for each row. All right, so now let's look at the result of the multiplication. The output from the multiplication is 4.9, 5.9, 7, 8, and 9. The output was supposed to be 5, 6, 7, 8, and 9. So is X indeed a solution to the equation AX equals B? In infinite precision, no, it's not. But if we were a little less severe than infinite precision. Let's maybe round it to 2 decimal places. Now, do they look to be the same? That'd be a yes. That's computational linear algebra. That's the kind of performance that we expect. So the key thing to learn here is we read the file one line at a time and put everything in the right place and then did some arithmetic. And here I have it fancied up. We're not going to do this part today, but next time after our little quiz, I'll show you how instead of what I had to do, which was to right click and download, we can program that activity in. At least if the file is stored on a server that's serving its contents through the HTTP protocol. Not the secure one, but the unsecure one. The only difference between secure and unsecure in the web world is whether all the intermediaries get money out of it or not. Because a secured website is every bit as unsecure as an unsecured one. The traffic's not encrypted, but that third-party certifying authority is getting money from the traffic. So it's all a money thing. It's not about protecting the computer or the mighty internet at all. Are there any questions? All right. Well, you'll be free to go in a couple seconds. I'm gonna go to my office and try to prepare an email that lab today is deferred, and I'll go ahead and put the morning lab video. I'll link it into your guys' section so you can look at that. I'm thinking in the group meeting when they created the exam questions, I don't think there's going to be much with files in it. There might be that download a file to get some data stuff, but I will probably, if that's the case, if we have to get data from files, we will provide in the actual lab part of the exam stuff that looks like that, and there'll be an instruction that says, run the cell exactly as is. Just run it, don't fuss with it. Or the other word that I almost let slip out. All right, you're free to go. If you're driving somewhere, drive pretty carefully, because the roads are already slippery. If you go out the Marcia Sharp to the west, there's a pretty bad accident at the flyover that connects to the loop. So you might want to take a different route. I mean, I didn't know there were that many police cars in the Lubbock area. They had every police car they could find, a bunch of trucks and ambulances. So was that.
For the dictionary, is it okay if I split it into 3?
Absolutely.
Okay, because I tried to run it as one just for like experiment, and like I couldn't figure out how to like get the desired.
Right, because you're trying to index a tuple. I don't know how to do that.
Okay, so the way I did
Break
it
into
is
3
fine.
parts is just fine.
Okay, thank you.
For the test, right? Do we require proctoring software? Is it
No.
online or
It'll be online. It's cheating enabled, so don't worry about that.
so just use our notes that we have online?
Yep.
Cool. Thanks so much. I got a program with the lab number 5. Yeah, can I tell that I tried to run this script? I get this message here that the add row is
Right. So where did you come up with add row?
I don't know, this was already there in the lab.
Oh, that's a directive. You need to provide the script to add a row. There is no add row
Oh, yeah,
function.
there is the add row. The add row. I checked the lab video and it has the same script, but
He defined add row as a function somewhere before He used-
Okay.
I don't think there's an add row method as a default.
I think it's
Add row as in like add code cell?
Add row as in
Okay, so
add a
then
row
that's
to a
fine.
list.
No, I don't think so. You can add item.
I think he created a function called add row. And what the function did is it took as input something and it used the append method that is part of the list. So it took a list as an input and what you wanted to add to it, and then had append the list name.
Okay,
So there is no add row function. That's why it doesn't work.
gotcha. So, but I need to here, try to look out for the attribution.
What I would do if I were super lazy, which I am, I would go to the mighty Google and I would type Python add row to list how to. Probably in that actual order.
Yeah.
It'll Boolean searches backwards anyway.
Okay,
How to add a row to a list in Python. That's all you need to type.
gotcha.
I guarantee you over 100,000 options.
At least,
95,000 of them won't actually be useful to you,
but there will be
Hey,
5,000 things you can use.
but there will be 50,000 somewhere near the top that will,
That we work for
Yeah.
this.
yeah, it may not be a direct cut and paste, but especially if it's Stack Overflow, there'll be a pretty good
Oh, don't
explanation.
do Stack Overflow because it's too difficult. Try YouTube. YouTube would probably genuinely
Okay.
work.
And Geeks for Geeks has good examples. So,
That's how I've solved all my.
yeah,
life
you've
so
done nothing wrong. You just have,
Yeah.
you have an undefined method.
Did you take roll?
I did.
I
You
got
were,
here like 10, 15 minutes late.
you're gonna get a big L then.
Yeah.
But no, L's are less bad than a 0. So
Wait, really? Do I get an L?
how late were you?
Like 10 minutes, but it's snowing.
Oh, gee.
I walked in the snow to get an L.
There, you got your one, you big baby.
There you go. That's. I walked in the snow. It's not supposed to get.
Say anything, there's a fat zero on there.
There isn't a zero on there. Yeah, I know. I remember I texted you Aiden that day. I was like, I physically cannot. I get off work at like 7:30 a.m. So some